Continuing on with week 6. I have it on my notes listed as class 6. I need to fix that. So here's a example from Dr. Bob's notes. It said undamped system has 8.75 kilogram mass, right? Suspended from a spring that has a constant of 3,500 newtons per meter. A harmonic force is acting on the mass that has a maximum value of 187 newtons, right? So that's going to be what I've been calling PO, right here, 187 newtons, right? And the system to vibrate with an amplitude, all right? So here's going to be the amplitude of the response, 7.6 centimeters, which we also know to be 0.076 millimeters. I think I did that right. Yeah, okay. And say, okay, so determine the frequency impressed force, omega F, in RPM, right? So what we can do here is first, given this information right here of the mass and the stiffness, I think the first thing to do is get the natural frequency. So get that out of the way as quickly as possible. And so you have 3,500, and you're dividing it by 8.75, and if that sounds like it's a very specific number, that's probably because they purposefully made it so it came out to 20. So tricky. And we can find out a magnification factor. Okay, so the main equation that we're going to use, I think we've written it in a couple different ways. Let's go ahead and write it in a useful way that we could go back to. Xm is PO over K. And it's going to equal to 1 over 1 minus R squared. I didn't have to put those parentheses in there, did I? So we haven't used that all the time, that particular thing, but we can right here. All right, so so they're telling us a bunch of things, right? So they're going to say, I guess I could I could approach this problem in a bunch of different ways mathematically here, but this is what I did on mine, right? So I said XM 0.076 meters, and then I divided it by the force, 187 newtons. And I'm going to divide that, so that means I'm going to multiply by the 3,500 newtons per meter. It's going to equal 1 over 1 minus R squared. So I can solve for R squared from this. The thing I think we're going to find in a second. So let me first get a value for this. So we're going to have to go 1 minus R squared is going to be equal to 1 over, and this is going to be the magnification factor, right? So I'm going to put all of this on the denominator. It goes 1.423. We also recognize that it's 0.7038, right? So when we go for the R here, let me double check something. Okay, so when we go for the R right here, we have okay, I see. All right, so R comes over the other side. This right here, we're going to subtract from R. So you're going to go 1 minus 0.7038. Subtract, and then take the square root. So I end up getting 0.54442. And so that's just a ratio. I think that there's another way that I can get to this, but let me just finish out the way that I have it there. So we have we know the natural frequency. We have it up here, and so we're going to have this omega n squared, omega f squared, divided by omega, nope, not squared, sorry, omega n, and it's going to be equal to 0.5442. Omega f is going to be equal to 0.5442 times 20. Did I do that right? Yeah, I think so. And what we will find is we get 10.90 radians per second, but we want RPM, so we will multiply it by 60 and divide it by 2 pi. So these are 60 is seconds per minute, and 2 pi is radians per cycle or revolution. So we will get from that, I should have actually written it this other way, but that's okay. We get 104.1 RPM. Now you'll see that there are two solutions, because if we go back over to here, for a particular magnification factor, which I briefly wrote into here, so let's see if we can find it. Let's put it right into here. Here's the magnification. Oops, didn't mean to do that. I meant to go. Let's see, can I get rid of that? Nope. Dang. I'm all kinds of messed up. Anyway, that was 4, 2, 3. And what I wanted to do was highlight it with yellow, that's our magnification factor, which would be somewhere close to what I just drew right up in here. So I kind of ruined it. Ruined the surprise. Didn't matter. You didn't want to be surprised anyway. Here is, once again, I'm in a highlighter. And so this is what, 4, 2, 4, 6, 8. Yeah, so it's going to be right around here, but I say 1.423. So like right in there, right here, and then also like right here, right? So that's almost nearly, so let's see, 1.1, 1.2, 1.3, 1.4, 1.5. All right, so we're going by 0.1s. So that right there is darn close to 1.3. So if you take, right, if you take, let's see if we can do this right here. You take omega f, and you say that's going to be 1.3 times omega n, right? You end up getting 1.3 times 20, which will equal, let's see, I think 26, because I can do that math, radians per second. So the forcing is going to be that omega f times 60 divided by 2 pi, and that turns out to be 248.3 RPM. So that is our other solution right in there. We could also do it mathematically. I meant to do that before making the video, and I don't want to try to do it on the fly. But it has to do with taking, plus or minus when doing the square roots of these right here, and that you'll be able to get the two separate solutions. But I don't have it written out for me, and I'm not going to attempt to try to do it on the fly. See you in the next example.